Alright, we're going to start our review on page 182, or 184, sorry, number 2. Number 2, it just wanted you to simplify. So the first thing we're going to do is we're going to take this 2x and we're going to distribute it through. That's going to give us an 8x cubed minus 10x. And then when we're subtracting a polynomial, we just have to remember to distribute that negative sign through, or we change the negative to a positive and change the signs after, however way you want to remember it. That's minus 7x cubed and then minus 3x. Putting together the x cubes, we get 1x cubed, and they're gone. Putting together the negative 10x and the negative 3x, we get negative 13x. Number 184, or page 184, number 3, they're asking us to factor this. Again, we want to factor it into two binomials. It's a quadratic. We have 3x and x. That's pretty easy because 3 is prime. The only factors of 2 are going to be 2 and 1. Can't put them in there yet because that's a 3. That tells me though the signs are both the same. Tells me the signs are both negative. So I'm going to put those signs in. And now when I want to put the factors of 2 in, the best place to put the 2 is here and the 1 is here. And again, check your outer. That's a minus 6x and your inner is a minus 1x. And that's your minus 7x. So we're done. Number 4 on page 184, we're looking to simplify this. Remember, when we're simplifying, we're not allowed to have that square root in the denominator, so we multiply top and bottom by that square root, and we're left with 3 square roots of 3 over 3, and the 3's cancel, and you're just left with radical 3. In number page 184, number 5, we're dealing with an absolute value problem. You have to remember to create two inequalities here. The first inequality is the exact inequality you see. The second inequality is going to be same thing inside. You change the inequality from greater to from less than to greater than, and then you change the side on the other side. Solving for this one, you subtract 2 from both sides. You get x is less than 3. Over here, you're going to subtract 2 from both sides. You're going to get x is greater than a negative 7. We take a look at the number line. Here's negative 7. Here's 3. We have to be, again, open circle on both. And we have to be less than 3 or greater than negative 7. So that's going to be your solution set. And when you try to write that solution set up as a compound inequality, just remember to put x in between your numbers numerically around x, and the inequality will always point to the left. So there's your answer. Number 6, you're trying to solve. So when you're solving a quadratic, you want to get ready to set that factoring technique up. So you want to subtract 6 on both sides to get that 0. Once you get the 0 on both sides, then we're going to look to factor. We have an x and an x. My signs are different. And then you can use, since it's a 1 and a 1, it's factors of 6. That will add up to be 5. It has to be a negative 5, so it'll be a negative 6 and a positive 1. Take each factor and set it equal to 0. So you get x equals a negative 1. And you get x is equal to 6. Okay? Moving to our next question. Only a couple more here. See if I can get this centered. There we go. Number 7, we're looking to simplify the sum of two radicals, remembering that when we're adding two radicals, we have to have the same radicand. So I'm going to look to simplify this. 75 is 25 times 3, and 27 is 9 times 3. The square root of 25 we can bring out as a 5. The square root of 3. The square root of 9 we can bring out as a 3. The square root of 3. When we're adding radicals, the radicands stay the same. You add the numbers in front. 8 square roots of 3. Page 184, number 10, our last question. Again, the directions were to, actually it looks like the directions were to simplify, but it's asking you for when this fraction is undefined. And one of the things that, if we haven't talked about, we will talk about. The only time a fraction is undefined is when the denominator is equal to 0. That denominator can then be factored into the difference of two perfect squares. And then solving for each one, you get x equals a negative 2 and x is equal to a positive 2. These are the values of a that will make this fraction undefined.